Hello everyone, in this video let's discuss how to solve the checksum related problem in the computer networks very easily. So this checksum is used for the error detection, and how to solve this problem means here we are having the different frames. So here we are having 1, 2, 3, 4. So total 4 number of frames are there, and in each frame there will be fixed number of bits. If you see in the first frame we are having 2, 4, 6, 8 bits. In second one also, third one also, fourth one also. In all the frames we will be having 8 bits itself. So you can write m is equal to 8. N is the number of frames and m is the number of bits. Now what this checksum will do is, it will check at the sender side also. It will check the message whether it is correct or not in the sender side also and in the receiver side also. So whatever we write in the sender side, just copy it in the receiver side. So now what we must do is, as the heading only says, check the sum. Checksum means check the sum. So we must add the frames. So what is the first step? Add all the frames. So now first let's take the first frame and the second frame. 1 1 0 0 1 1 0 0 1 0 1 0 1 0 1 0. So the trick, and now when you are adding, if you get carry equal to 1, at last if you get the carry equal to 1, then add it to the LSB, that is the least significant bit. Now I will show here. So the trick to add is, 1 plus 0 will be 1 itself, 0 plus 1 will be 1 itself, but 1 plus 1 will be 2. But you can't represent it using 2 itself. You must represent it using zeros and ones. So how means 2 power 0, 2 power 1, 2 power 2, 2 power 3. 2 power 0 is 1, 2 power 1 is 2, 2 power 2 is 4, 2 power 3 is 8. So if you see here, we just need 2. So what I will be doing, I will be putting 1 to 2, and I don't need 1, 0, I don't need 4, 0, I don't need 8, 0. So what happened? Only the 0 after the non-zero element will be considered. So 1, 0 will be considered for 2. So whenever 2 will be occurring, just write 0 at the sum and 1 will be the carry. Next, when you want 3, so here 2 plus 1 will be 3. So these 2 will be considered. So 1 will be written in the sum and another 1 will be given as the carry. So now let's solve the problem. You will understand easily. 0 plus 0 will be 0, 0 plus 1 will be 1, 1 plus 0 will be 1, 1 plus 1 will be 2. How you will represent? 0 will be the sum and 1 will be the carry. 1 plus 0 is 1, 1 plus 0 is 1. Next, 0 plus 1 will be 1, 1 plus 0 will be 1. Next, 1 plus 1 will be 2. How you will represent 2? 0 will be the sum and 1 will be the carry. Now what is the second step? If carry is equal to 1, then add it to the least significant bit. That is, this is the least significant bit. You will be adding it to the least significant bit. 0 plus 1 will be 1. Next, all will be same. 1, 1, 0, 1, 1, 1, 0. Now we got the answer by adding the first 2 frames. So now what I will be doing is, I will be adding the third frame. So this is the third frame. 1, 1, 1, 1, 0, 0, 0, 0. Now add them. 1 plus 0, 1, 1 plus 0, 1, 1 plus 0, 1, 0 plus 0, 0. 1 plus 1 will be 2. How you will represent 2? 0 will be the sum and 1 will be the carry. 1 plus 1 will be 2, 2 plus 1 will be 3. How you will represent 3? 1 will be the sum, 1 will be the carry. 1, 2, 3. 1 will be the sum, 1 will be the carry. 1 plus 0 is 1 and 1 plus 1 will be 2. So 2 means 0 will be the sum, 1 will be the carry. Next, if you get carry as 1 at the last, you will be adding it to the least significant bit. So 1 plus 1 will be 2. How you will represent 2? 0, 1 carry. So 1 plus 1 will be 2, 0, 1 carry. 1 plus 1 will be 2, 0, 1 carry. 1 plus 0 will be 1. So 0, 1, 1, 0. Now the last one left is the fourth frame. So let's add it. 1, 1, 0, 0, 1, 0, 0, 1, 1. So 1 plus 0 will be 1. Next 0 plus 1 will be 1, 0 plus 0 is 0, 1 plus 0 is 1, 0 plus 0 is 0, 1 plus 0 is 1, 1 plus 1 will be 2. I will represent 2, 0 will be the sum and 1 will be the carry. So 1 plus 0 will be 1, 1 plus 1 will be 2. So I will represent 2, 0 will be the sum and 1 will be the carry. At last you are left out with 1 as the carry. So when you are left out with 1 as the carry, what you will be doing? You will be adding it to the least significant bit. So 1 plus 1 will be 2. So 2 means 0 will be the sum, 1 will be carry. 1 plus 1 will be 2. 0 will be the sum, 1 will be the carry. 1 plus 0 will be 1 itself. So 1, 0, 1, 0, 0. So now you got the remainder. So what is the remainder we got? 0, 0, 1, 0, 1, 1, 0, 0. So the next step is just copy what you wrote in the sender side towards the receiver side also. Same you must copy there also. So now what we will be doing is we will be adding the remainder and the checksum. Remainder and the checksum. So how to add the remainder and checksum means, here we got the remainder 0, 0, 1, 0, 1, 1, 0, 0. Now if I want to add the checksum. So what is the checksum means? Checksum is the reciprocate of the remainder. That is 0 will become 1, 1 will become 0. So 1, 1, 0, 0, 1, 0, 1, 1. So just reciprocate the remainder value as the checksum value. Now if you had 1, 1, 1, 1, 1, 1, 1, 1. So all of them after adding the checksum and remainder, we got the answer as 1s. So now what you must do is you must complement it. You must complement it. So when you complement it, it will be equal to 0, 8 zeros. So when you complement the answer that you got when you added the remainder and the checksum, and if you got the value as the 0, so then you can easily conclude that the given problem is satisfied. That is, no error detected in the message which has been sent from the sender towards the receiver side. So what you did, you just wrote for the sender side and then you copied for the receiver side. So you know the trick here, how to solve the problem, and if there was a carry while adding, you just added to the least significant bit. So at the last step, after writing the receiver side, you must write the remainder with the checksum. And when you complement the sum of the remainder and the checksum, if you get the 0 as the answer, then you can write that the message which has been sent from the sender side has been sent to the receiver side without any error, and it is accepted at the receiver end. So hope you understood the topic of the checksum in the computer networks. If you have any doubt regarding this topic, please do comment below. And if you liked the video, please subscribe and support us, because your one support motivates us to make more engineering related topics. Thank you.